Hello, everyone. So this is scaling AppSec through education. Just a quick who we are, secure delivery. The takeaways from the slide are that we do this sort of thing commercially, that we do this at scale with some large companies, but it's all built on OWASP projects, especially the OWASP Open Application Security Curriculum, of which I am one of the project leads. I also lead the OWASP Cornucopia project with Colin Wilson, and I'm currently on the global board. Takeaway from this slide is my handle, REWTD, Root Demon, under which you'll find me on the Slack, on Twitter, LinkedIn. My DMs are open, so please give me feedback on the things that you hear today. So this is scaling application security in large organizations, and we have very little time. So forgive me upfront, this is going to be a very compact, very dense talk, but let's continue the conversation afterwards. So to start thinking about application security, we have to first define it, put a little box around it so that we're clear on what it is exactly we're covering. Cybersecurity is very broad. It covers corporate identity, email security, desktop OS updating, file shares, especially recently, printers, and there's a lot going on. But we're concerned with the part of cybersecurity that you have to deal with when you're building your own software. So the systems can be as secure as designed and built, but they're also the ways that how you're building them can screw you over from a security point of view. So someone could push production passwords or cloud API keys to a public repository. A sketchy person can approach one of the developers in your team outside of work and offer them an eye-watering amount of money. Just add a little backdoor. Supply chain attack. Open source library you use could get some nasty code introduced to it. And you pull it on the next build of your system. You're not aware that it's there. There are many, many more ways. So if we're talking about the quality of supply chains, materials, value-add activities, and design and manufacturing processes, then what we actually mean by application security is product security. That's pretty clear, but security is an intrinsic quality of a system sounds a bit philosophical. So let's try and define that a little bit too. This is the ISO IEC 25010. The system and software quality model. Generally, ISO models are designed left to right of importance. Quality model is connected to how systems provide value. So, most important is furthest left. You might think that reliability is more important, but with a system, if a system has 5 nines uptime, but that's incredibly slow to use, you're going to see that your customers drop off and your customers will find it completely useless. Now, security sits on the border between things that people care about, the non-functionals that people care about, and that can easily see, and the non-functionals that people don't care about much and can't really see. For example, if I pushed a change to production that negatively impacted performance, it would immediately be visible. Our customers would know it. They would complain. They'd be held to pay. If I pushed a change to production that negatively impacted security, something might happen, but something might never happen. And as Toby is fond of saying, hope is not a strategy. When deadlines pinch or resources get limited, it's pretty predictable that you'll see that these qualities will drop away from right to left, leaving ultimately just functional, the thing works. This, in addition to the team simply being unaware of the requirements that might be in place for security for a particular non-functional security in my case, is when you end up with technical debt. Whenever I say the word technical debt, or whenever somebody at secure delivery says the word technical debt, what you should think about is low quality, because it's all about quality. So product security is one aspect of its overall quality. So how do we ensure appropriate high levels of security quality exist? Well, a pretty common way to think about managed security is this line, where rapid delivery of changes to production, so at one end of the scale, being secure is at the other end. And as an organization, you kind of pick somewhere on there. This is where our comfortable spot is. This is what we're happy with. It makes intuitive sense because as human beings, we think about moving quickly as carrying some level of risk, like driving a car at high speeds. The problem with that intuition when applied to application delivery is that it's completely wrong. I'm not saying that we should rush everything, it'll be fine, but rapid delivery and high quality are not opposed to each other. In fact, they complement each other. They work well together. Having the ability to develop and release changes to production quickly means that you can more quickly respond to issues, find the issues and fix them quicker. Security issues quicker. You probably have automated deployment processes, which removes an error and an element of human error, opportunities for malicious intent or other reliability on other aspects. You probably have automated testing processes, which increases the functional correctness, the things that we care about, things that most people care about, and the other non-functionals, because you're regularly testing that you're not seeing any backsliding in that area. You've probably got code that's clear, straightforward, easy to extend. You're not handing off changes to other teams for assurance or for deployment. These things are just advantages, both from a security point of view and from a quality point of view. You can't deliver at pace unless you're paying attention to the non-functionals. It's just not possible. Performant, interoperable, reliable, usable, maintainable, secure systems can be changed with confidence. Low quality systems, that are harder to change, tend to be brittle, unmaintainable, unreliable, insecure, slow. This low quality system simply can't be changed quickly. They'll functionally fall apart if you try to, and everyone is quite correctly scared to even attempt it. Every change leads to unpredictable failures in overly complex systems. Slowest release projects tend to be the ones that have the lowest quality. Delivering slowly isn't more secure. It's fearful. And if you're afraid of changing a system, that system is not secure. Taking all of this into account, security incidents are trailing indicators of low software quality. The problem set in long before that incident happened. Trailing indicators confirm long-term trends, but they don't really help to predict them. They're a terrible measure to base your organization decision-making on, and you shouldn't be choosing how you spend money that way either. Which is why massive rebudgeting and shakeup when you're responding to an incident is terrible, but that's generally where budget funding comes from. So how do we manage security quality when we only have trailing indicators? Well, what we need to do is find something that aren't trailing. We need to find some leading indicators of software quality. Get ahead of any potential incidents. So if we had trailing indicators, then leading indicators, then we'd have a good measure to base our decisions on. So the four metrics that matter. These are, I'm not going to go into a lot of detail on them. If you don't know about the four metrics that matter, you need to go out and get a copy of Accelerate. You need to read it. But if you're doing well with these four metrics, you're delivering product to your business, to your organization at the right speed, you're doing things the right way, you're delivering high quality product, you have good leading indicators of how high performing your high software quality delivery is. Now, these are obviously not absolute figures, they're very much relative. But if you notice that functional correctness doesn't actually impact any of these things, right? You can build a completely wrong system, a system that doesn't work, a system that doesn't do what your customers need it to, but we're really high quality. But non-functionals do impact all of these. So any one of the non-functionals is affecting a great deal affecting these four metrics. So security is interesting in that improving security of systems doesn't actually improve these metrics, except if that we do it the wrong way. If we implement security features or implement security processes wrong, then we will negatively impact these things. So we need to aim for a minimal impact as possible while improving security, and we need to keep track of these metrics while doing it. So these metrics are useful to tell us that we're producing quality software. These metrics are also useful to tell us that we're not impeding the ability of the business to create software or to produce new versions with our security effects. In this study of root causes of all common vulnerabilities and exposures reported in the 8 years from 2008 to 2016, essentially said that almost all of our problems are in implementation, in code. And it makes sense, right? There's only so many ways that you can mess up a configuration. There's only so many ways that you can design something incorrectly. There are countless ways that you can screw up while coding. It's an incredibly complex endeavor. It's really hard to do. The traditional focus of cybersecurity, design reviews, config hardening, it tends to sit in this little box. It's useful, but it's not the whole picture. It's definitely not the whole picture. So most product security lies in preventing security defects in code from reaching production, fixing the ones that are already there, having a measure for security defect density in code from a security testing tool. It's a good direct metric for security quality. But what are the next steps? Well, if we wanted to ensure performance in systems, right? Performance is easy because it's something that we measure. We have a pretty good understanding of what performant code should look like and what that means for our end users. So let's start with performance and move on to security. If we're going to be doing something from a security point of view, from a performance point of view, we want to think about what that impact will be. Think about the performance impact of any change that we're going to make. We're going to plan our architecture with performance in mind. We want to ensure that everyone knows how to write performant code in the languages and frameworks that we're using. We want to hire people with domain expertise on performance so they can help push performance as a key component of what we're doing, so they can train our other users to make use of that. We're going to do peer review of code changes, looking for performance issues, because we now know what we should be looking for. We're going to share known performant code with the rest of the organization. If we have internal libraries that are exceptionally performant, we'll make sure that we use those everywhere. We'll make performance a key consideration when we select third-party services or third-party libraries or third-party components. We'll automatically test all changes for any performance defects, any performance regressions on every commit, so that developers can see immediately, hey, I made a change here and it affected the performance of the system. Catch it early, fix it early. We'll prioritize performance fixes in our backlogs, in our development cycles, because it's important to us. We'll inject telemetry to measure performance in production, just to show how performant our systems are. We'll investigate and fix any performance issues that we find in production, making sure that we keep that, that standard high, and publish our findings and publish what we've done to ensure that it stays performant across the organization to improve more learning. We'll have responsibility and accountability for performance with the people who are building the systems. We'll make it their responsibility to make sure it stays performant. If we're going to do the same thing for security, it's going to be exactly the same, right? Now, some of this we can measure and we can make visible. We can have a record of developers who've had secure coding training. We can have a team with only developers who haven't had security training. We know that they're more likely to make security issues, cause security issues, so lower security quality. We can check GitLab or GitHub or whatever your version control system is for evidence of pull requests and reviews that show that peer review is happening. We can check Jira or any other work tracking system for the age of items marked as security work to show that known issues aren't just being deprioritized or ignored. We can check build logs, test logs in our orchestration platforms for evidence of security tool test runs. And we should have those security tools in place, Daniel pointed out. And we can pull all these delivery metrics, direct code level security, testing output, and evidence, good ways of working together to create strong indicators that we have good product security under control. How do we do that at pace, though? Well, we've already got an example in SRE, right? We have experts in the field of reliability. They build self-service platforms, which is important so they don't become the bottleneck themselves. We have SLO, service level objectives, because it costs a lot more to build a 5 nines or 6 nines system than a 2 nines one. So agreeing what product requirements is pretty essential. We have service level indicators, which are relatively straightforward for reliability, right? Is the system up or down? How long has it been down this month so far? And the operating model is pretty basic too. It's simple, it's data-driven, takes away all of that emotion about what's going on. It provides a self-regulating back pressure on the product team. So if they let reliability go down, it changes the system over time, it gets pushed back to them. Product team that has production support responsibility handed back to them has a strong incentive to now focus on those non-functionals, right? To get reliability back to where it needs to be. SRE won't take production support again until reliability is back where it needs to be. Developers don't like being woken up 3:30 in the morning. So yeah, can we apply the same approach to security? Sure, we can. Product security engineering. It's basically the same. Same as being part of it. It's just part of an engineering function. There's an adjustment required for some security teams to become that internal consultancy with an education focus, but a lot of teams are already doing that. A lot of organizations are already grouping systems based on criticality with greater security requirements. So critical systems have also higher security requirements associated with them. So you just need to specify where the security level indicators need to be for each of those groups. We don't yet have one clear service level indicator. So we have to combine multiple indicators to create composite SLI. So we'll go out and get some other metrics around that, like whether the devs have done the training, that sort of thing. And how best to provide back pressure is going to vary from organization to organization, right? We've made security visible through SLIs, but without back pressure, the product teams can't self-regulate for security. And unlike security, you're not going to get a series of like smaller security incidents that lead up to a big one. Failure mode in security is pretty immediate. So you won't hear this month we've briefly been hacked twice. So we need to ease back on feature work and focus more on security, so we don't get hacked anymore. That's not something you'll ever hear. So we need to have strong incentives for product teams to keep the indicators where they need to be. You'll need to be able to answer these questions: who's contributing to the system, who's helping with the code, who's helping with the design, who's making the product decisions, what subsystems make up the system, what components make up the subsystems, which code repositories map to those. And from the bottom up, you need to go from source code that might be demonstrating a problem right away to components, subsystems, systems that are built from that repository without ever asking people, right? People come and go, software tends to stick around usually longer than it should. If you can't do this from an engineering point of view, then the organization has no chance of getting its act together, and it will have no chance to build high quality secure systems or respond to identified problems in the right way. So I'm going to this brings us to secure software development training. So the how of it all. So today I want to talk about the latest attempt OWASP has made to standardize and codify curriculum for secure software development. It is an OWASP initiative, and I'm a huge OWASP fan. I'm a huge fan of the open source approach to building stuff, because things then happen in the open. Anyone can contribute. It also makes sense to use OWASP projects that set the standard for measuring software quality, like the ASVS, and that the standards for development maturity, like SAM, and to use the great work done in those areas. We also leverage cornucopia, although that's because it leverages the same projects and covers everything from design principles as well. And the top 10, because that's where everything starts. Starting, let's kick off with fundamentals. Top 10, although there are several of them, is where most teams start to look at product security. And it's from the most common defects rather than how to build things right. But the original top 10, the one that's being updated this year, that's going to be talked about a lot today over the course of the next 24 hours, is still indirectly referenced by the PCI DSS, despite not being a standard. It is a good place to start, though. Andrew Van Stock, who is the current top 10 project lead and the ED for OWASP, said at this year's Developer Summit that top 10 is a good place to learn to crawl from. So let's start there. This is the new top 10. Briefly, as I said, because there's going to be lots of presentations on it today, and lots of people will be talking about it over the course of the next couple of weeks, are the items on the right side of this list. And the updates made a couple of changes to the list, although it seems that we're still stuck with injection attacks, but they have dropped slightly lower now. Mostly attention's been made to naming. It's been key. Grouping of types of attacks that we've seen previously, and there are a few new ones. So if you look at the top 10 just broken up here a little bit, you're seeing that there's a lot more happening in building errors. There's been some renaming, shifting around of things. And as I said, there'll be lots of discussion about it today. Now, the ASC 101, or the ASC Foundation, Application Security Curriculum Foundation, covers the top 10. This slide is directly taken out of the sample presentation material for the ASC 101. And this is what it covers. It's who it's aimed at, and it's what you need to know going into it. There's a slide like this one for each of the top 10 with some speaker notes that are based off of our expert experiences, team that's been involved in building it. Definitely go check it out. It can be found over here. And I'd like to just do a quick shout out to HMRC, Her Majesty's Revenue and Customs, the UK Tax Department, who actually helped us build this piece of work. And we're happy to contribute it back to OWASP and to us as a foundation. But what comes after that basics? Well, for me, it's cornucopia. Because architecture is revolutionary and cornucopia allows developers to use knowledge they learn through the game to evolve thinking about threads, modeling as the architectures evolve. Cornucopia itself stands on the giants that follow, but it simplifies the more complex standards we're going to try and get to. And it creates a top 5 of places to consider doing security user stories, or a spike, or adding a security NFR, or some acceptance criteria. If you don't know it, Cornucopia is a game, a card game to be precise. It's based off of Adam Shostak's EOP, Elevation of Privilege. EOP covers gamifying threat modeling for security teams, while Cornucopia does the same thing for developers. The point of view simply shifted left slightly. Now I have hours of presentation and demonstration materials in Cornucopia. But if you want to learn how to play, then this video is a good place to start. And feel free to reach out to me at RDWDT for a deck of cards, or for beta access to the online version that we're currently working on. I have hours of these slides, so I'll just click straight through them. The top 5, as I said, is made of 6 suits. There's authentication, who you are, authorization, what you're allowed to do, session management, how often we check the auth, cryptography, the secrets, the hashes, the poor choices, you know what I mean. Anyway, moving right along. Data validation and encoding, making sure that everything crosses the security trust boundary is safe. And then a catch-all, because stuff just never works out. So how do we use Cornucopia as an educative tool, though? Well, we play the game. Actually, as a security person, what you do is you teach developers the game, and you give them the materials that come with the game, and then let them play. Otherwise, it's a little bit like playing Cards Against Humanity with your parents. To cover off the do threat modeling part of things from a compliance perspective, you tag your stories in Epics and Jira, you scan in your score sheet, and that gives you something to show the auditors to feel fuzzy about, while you know that things are being done the right way. But how do you level up from that? Well, there are 2 possibilities, and this is where most of the work is still happening. To begin with, wanting to make secure software development a skill that developers can gain while learning to code or learning the right coding practice. Most of us start coding very early, so maybe it's not while you're learning to code. So we're targeting tertiary education, firstly, with an eye to develop skills into modules, and then stack those modules up to cover the whole of build a secure thing space. Basically, the ASVS is OWASP's answer to the question, what is the standard against which software can be measured for security? Because it is a standard. And as a standard, it has had to go through a lot of rigor and scrutiny. Although perhaps never more so than when Toby and I decided it would be a good basis for the curriculum. The 1,000-foot view of the ASVS, in case you've never heard of it, there will be a presentation on it today. But the first thing you need to know about the ASVS is that it's split into 3 levels. Each application, each is applicable to a different type of app. Level 1 should be used on all apps, and it can be tested for using DAS tools alone. Zap's a great way to test level 1. Every app should try and get tested to level 2. But if you go beyond 1, then you need to look at code and code review and code designs to do full testing. Level 3 is for apps that are serious about security. And if you manage special categories of data, or if you connect to systems that do, like bank accounts, patient records, then you should be looking here. There's also technically a level 0, which is what any application assessed that didn't meet the requirements for at least level 1 is tagged as being. If you do use level 0 in your organization, you probably want to document what a pass at level 0 means, or just realize that it means it's been tested but didn't pass. The areas for learning in the ASVS cover everything from architecture, which is not tested in level 1, through to details about configuration, which are very tested in level 1. And it includes the domains from cornucopia earlier, so authentication, access control, authorization, session management, validation, and cryptography. To assess at level 3, though, is to cover off 286 requirements. So how do we break this down for teaching? Well, we break down all the ASVS requirements into actions and into terms. We group the terms into units and weigh the actions described against Bloom's taxonomy. Now, Bloom's taxonomy, or more accurately, the cognitive knowledge domain of that taxonomy, describes 6 levels of learning, from remember through to create. It's a standard applied by educators around the world, and being hierarchical, in order to understand, or to successfully understand, you need to first remember. To apply, you need to remember and understand. So remembering is retrieving, recognizing, recalling relevant knowledge, long-term memory, understanding. There's details on each of them here. Well, level 6 is technically possible. We've not found cause for it to be in the ASC yet. We've also yet to see a level 2. The process is as follows. We take a requirement from the ASVS, like this one. We identify the actions. We then identify and collate the terms, and we apply some magic to determine the Bloom's level required to fulfill that requirement. This results as the basis for the curriculum. What knowledge is required to build something that meets this requirement, or to evaluate whether it does. Obviously, the next steps here are to find information on each term, or make a note to the standards authors about the term, or add a knowledge-based article or some combination of the above, and then build teaching materials for those terms grouped by those units. Now, when we covered off ASVS in the tertiary section, everything gleaned there can and must also become available through industry training. So imagine that all the previous work is also broken down into parts that can be consumed in 1, 2, or 5, 3, 4, or 5 days, in increments that are grouped together in a job-shaped course with related modules, rather than units that were previously discussed to build up the whole structure. All of this is still work in progress. In this section, we're going to talk about OWASP SAM, where ASVS is about building a secure thing. SAM is about building a thing securely. When it comes to telling folks how they should build software securely, you need to be prescriptive, which is one of the reasons that we've picked this SAM over something else. The other is, of course, that it's an OWASP project, and you may have noticed how much we like OWASP projects. Now, SAM is made up of 5 business functions, with each business function being a category of activities that organizations developing software must somehow perform. Each has 3 related security practices, which are grouped security-related activities to support them. Security practices each have 6 activities grouped in logical flows, divided into 2 streams, and then split across the 3 maturity levels, giving us a total of 90-odd requirements. Streams cover different aspects of a practice and have their own objectives, aligning and linking the activities in the practice over the different levels. All of this, there will be presentations on today as well. Please actually go and listen to them. The learning areas in SAM cover activities from overall governance and education. Hey, that's an idea. All the way through to operational concerns like managing incidents. As before with ASVS, we take the activities and we break them into actions, and we take those and break them into terms, and then go through the weighing process. There are fewer activities in SAM than there are requirements in the ASVS, which is yay, that's good. But the activities are more complex. Damn. We follow the same process as before, this time gathering the actions from a given function / practice / stream and a given maturity level. We then group the actions and modules, and then the rest is identical. So how do we apply this training in practice? Well, foundations, just go out and get it. or have us come in and help you to present it to your teams. We make it really live. We've got loads of success with it. We make use of some cool tools that make it more interactive and more fun. Intermediate training, well, use the game. So play it with your teams. Reach out to us for a deck of cards or for beta access to the free and open digital edition, or have us come and play with your teams and teach them to play for you. Tertiary education and industry training is still a work in progress. We've built parts of the whole. We're able to present them to your teams, but that's not the point. The point is for this to become a standard and for everyone to have access to all of it. We'll continue to build out what's there until that is the case. So what does the future hold? Well, help us to complete the mappings and to work on building modules and units, and then creating slideshows and speaker notes. Sponsor the project, like HMRC has by engaging with us, or through the OWASP grants process that's listed here. There are already 2 organizations that are keen to get involved in this, and I hope to be working with them over the course of the next couple of months to get the next pieces out there. Give us your feedback. My OWASP email address is there, along with my Twitter, and I'm here on Slack as well. So reach out to me on Slack and chat to me there. Thank you very much. I hope that this, I know it was incredibly fast, but I hope this was a useful session for you all.